Chapter 4. Air. The envelope of air which surrounds the Earth is called the atmosphere. Considering the size of the Earth, the atmosphere is a relatively thin layer. The atmosphere is held to the Earth due to its gravitational pull. The total weight of the Earth's atmosphere is about 500 million tons. About 99% of the total mass of the atmosphere is found within 32 kilometers from the Earth's surface. The atmosphere is a mixture of colorless, odorless and tasteless gases. The main features of the composition of the atmosphere are as under. 1. Air is a mixture of gases, water vapor, dust particles and smoke. 2. The two main gases present in the atmosphere are nitrogen, about 78%, and oxygen, about 21%. 3. The other gases present in the atmosphere are carbon dioxide, helium, ozone, argon, hydrogen, etc., about 1%. 4. The lower layer of the atmosphere contains water vapor and dust particles. 5. The amount of water vapor and dust particles varies from time to time and from place to place. 6. Heavier gas, like oxygen, is mostly found in the lower layer. The composition of air varies from place to place and from time to time. However, the composition of clean and dry air is fairly uniform in the lower layers, up to a height of about 8 km from the mean sea level. Nitrogen is the most prevalent gas in the atmosphere. But plants are not able to absorb nitrogen directly from the air. Bacteria in the soil and roots absorb and change its form so that plants can use it. Oxygen is the most important gas. All living organisms need it to survive. They breathe oxygen present in the air. Carbon dioxide is important because of its ability to absorb heat. It is responsible for the greenhouse effect on the Earth. The amount of carbon dioxide exhaled by humans and animals is almost equal to the amount absorbed by plants. The amount of carbon dioxide in the atmosphere is gradually increasing. Structure of the atmosphere. The atmosphere has a layered structure. Its total extent can be roughly divided into 5 concentric layers: troposphere, stratosphere, mesosphere, thermosphere and exosphere. Troposphere. The troposphere is the lowest layer and is closest to the Earth's surface. Troposphere is the most important layer, as all weather phenomena like the formation of clouds, fog, frost, dew, thunder, lightning, precipitation, etc., occur in this layer. This layer protects us from the excessive heat of the sun during the day and keeps the Earth's surface warm at night. Stratosphere. The stratosphere lies above the troposphere. Its estimated height is about 50 kilometers above the mean sea level. The temperature remains constant up to a height of about 20 kilometers and then increases with increasing altitude. The lower part of the stratosphere, between 15 kilometers and 35 kilometers, has concentration of ozone and is thus called ozonosphere. Mesosphere. It extends from about 50 kilometers to about 80 kilometers above the mean sea level. The temperature decreases with height and reaches about 100 degrees Celsius at the height of 80 kilometers. Thermosphere. The thermosphere lies above the mesosphere. It extends from about 80 kilometers to about 400 kilometers above the mean sea level. In this layer, the temperature increases rapidly with the increase in height. One does not feel warm in this layer, as thin air holds little heat. Exosphere. The exosphere is the uppermost layer. Very light gases, like hydrogen and helium, are found in this layer. The exosphere merges gradually into outer space. Importance of the atmosphere. The lower layer of the atmosphere has life-giving oxygen, which is needed for breathing. Nitrogen and carbon dioxide are needed by plants for their growth. It prevents the sun's harmful ultraviolet rays from reaching the Earth's surface. It acts like a greenhouse and controls the extremes of temperature during day and night. It softens the sun's glare during the day. The change of weather and climate is due to the presence of atmosphere. The presence of water vapor causes condensation and precipitation. Sound waves travel through air. It shields us from meteors. Weather and climate. We use a variety of terms such as hot, cold, sunny, cloudy, windy, rainy, sultry, etc. to describe weather conditions. Actually, these terms explain the atmospheric conditions with respect to air temperature, air pressure, movement of the air, humidity, etc. These are the main elements of weather. Weather is defined as the state of temperature, atmospheric pressure, winds, humidity, precipitation, etc. in the atmosphere at a given place and time. The term weather should not be confused with climate. Climate is defined as the average overall condition of the temperature, atmospheric pressure, winds, humidity, precipitation, etc. over a large region for a long period of time. Therefore, climate is the average weather condition over a large area for a period of about 35 to 40 years. The conditions of the different elements of weather keeps changing. This change can take place anytime. Thus, the change in weather is a continuous phenomenon. But the climate of a place remains more or less the same year after year. Difference between weather and climate. Weather. Climate refers to short-term atmospheric conditions experienced at a specific time and place. Describes long-term patterns of weather in a particular region. Includes elements like temperature, precipitation, rain, snow, wind, storms, humidity, and sunshine. Involves factors such as average temperature, rainfall, wind patterns, and atmospheric conditions. Changes frequently and can vary from day to day and place to place. Changes slowly over a long period of time. Can be unpredictable and influenced by local factors and daily fluctuations. Can be predictable and based on historical data and trends. Observed and measured using weather instruments and stations. Analyzed through long-term data collection and analysis. Examples: sunny day, rainy afternoon, thunderstorm. Examples: tropical climate, arid climate, temperate climate. Studied by meteorologists. Studied by climatologists. Atmospheric temperature. The sun radiates heat and light energy. This is called solar radiation. It is the main source of heat and light for us. However, only a very small part, about 1 in 200 million, of the solar radiation is able to reach the Earth's surface. The amount of solar radiation received by the Earth's surface is called insolation. The word insulation has been derived from incoming solar radiation. The amount of insolation received on the surface of the Earth varies from place to place and from time to time. The Earth's surface absorbs maximum solar radiation during the day. At night, the heat which was absorbed during the day is radiated back. This is called terrestrial radiation. Measurement of temperature. The instrument used to measure the temperature of free-moving air is called thermometer. The most common temperature scales in use are the Fahrenheit and the Celsius. On the Fahrenheit scale, the melting point of ice is 32 degrees Fahrenheit and the boiling point of water is 212 degrees Fahrenheit. On the Celsius scale, it is 0 degrees Celsius and 100 degrees Celsius respectively. Heating of the atmosphere. The solar radiation which passes through the atmosphere, before reaching the Earth's surface, does not heat it much. But, the solar radiation is able to heat the Earth's surface directly. The air resting over the Earth's surface gets heated due to contact with the hot surface of the Earth. This heat is further transmitted to the upper layers and the atmosphere is heated. Distribution of temperature. Air temperature is not the same everywhere. It also changes from time to time. The temperature of a place is directly dependent on the amount of insolation received by that place. In general, the amount of insolation received decreases as we move from the equator towards the poles. On the basis of the amount of heat received by the Earth's surface, the world has been divided into 3 heat zones. Torrid zone. This is a zone between the equator and extending to Tropic of Cancer in the north and Tropic of Capricorn in the south. This zone receives maximum amount of heat as sun rays is almost direct all throughout the year. Temperate zone. This zone lies between the Tropic of Cancer in the north and Arctic Circle. In the south it extends between Tropic of Capricorn and Antarctic Circle. It receives moderate insolation. This zone is not too hot nor too cold. Frigid zone. This zone extends between the Arctic Circle to the North Pole in the northern hemisphere and the Antarctic Circle and South Pole in the southern hemisphere. This zone receives minimum insolation as it receives slanting rays of the sun. Temperatures are very low in this zone. Atmospheric pressure. Like any other matter, air too has weight. The atmosphere exerts its weight as pressure on the Earth's surface. This is called atmospheric pressure. The weight of an air column, standing over 1 square centimeter area of the Earth, is more than 1 kg. The weight of the air column is maximum at the mean sea level. The atmospheric pressure is measured with the help of an instrument called barometer. The normal atmospheric pressure at sea level is about 76 centimeters of the mercury column in the barometer. Millibar, MB, is the unit for measuring atmospheric pressure. The height of 3 mm of mercury column in the barometer shows 4 mb of air pressure. The air which rests on the Earth's surface expands on being heated and becomes light. It rises upward and creates an area of low pressure. In contrast, the cold air contracts, becomes heavy and settles down. This creates area of high pressure. Air moves from a region of high pressure to a region of low pressure. The weight of the atmospheric pressure on our body is several tons. But we are rarely aware of it. This is because while air presses our body from all sides, our body also exerts counter pressure to balance it. Distribution of atmospheric pressure. Atmospheric pressure is highest at the sea level. But on the mountains, the thickness and density of air column is less and hence the atmospheric pressure is also less. The atmospheric pressure on the surface of the Earth is not the same. This is due to unequal heating of the atmosphere. Normally, the atmospheric pressure should increase from the equator towards the poles. But it is not so. At some places it is modified by the Earth's rotation. There are 7 major pressure belts on Earth, and these are not continuous. The main pressure belts found on the surface of the Earth have been divided as under. Equatorial low pressure belt. The region around the equator is generally the hottest. Therefore, the air in this region heats up, expands and becomes lighter. Thereafter, the light air rises and creates a low pressure belt in this region. This belt is also called the doldrums or the region of calm conditions. There is a complete absence of surface winds. Subtropical high pressure belts. These belts of high pressure exist near 30° N and 30° S latitudes. The air that ascends in the equatorial region starts to descend here after losing its temperature. The descending air starts to pile up and collect near the tropics, creating a high pressure belt. This belt is also called the horse latitudes. Subpolar low pressure belts. These belts extend around 60 degrees latitude in both hemispheres. The rotation of the Earth causes low density by swinging the air in the direction of the equator. This creates a partial vacuum, creating a low pressure belt. Here, the air column is so thin that the air can hardly exert any pressure. Polar high pressure belts. Around the north and the south poles, the air is so cold and heavy that it is unable to leave the surface. The weight of the cold air creates high pressure belts over the poles. These high pressure belts are called polar high pressure belts. Winds. Air blows from a high pressure region to a low pressure region. Air that moves horizontally is called wind. The vertical movement of air is called air current. Wind is named after the direction from which it blows. If the wind blows from the western side, it is called west wind. Due to Earth's rotation, wind is deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. The speed of the wind also varies greatly. If there is a quick change in atmospheric pressure, it causes the wind to blow fast, and vice versa. Planetary winds. Some winds blow constantly in a particular direction throughout the year. These winds are known as prevailing winds or permanent winds or planetary winds. These winds originate due to the presence of permanent high pressure and low pressure belts on the surface of the Earth. The main types of planetary winds are the trade winds, the westerlies and the polar winds. Trade winds. These winds blow in the area extending between 30° N and 30° S, known as the tropical zone. The winds blow from northeast direction in the northern hemisphere and from the southeast direction in the southern hemisphere. The westerlies. These winds blow from 2 subtropical high-pressure belts, one in each hemisphere between 30° and 35° N and S, to subpolar low-pressure belts, 60°, 65° N and S in both the hemispheres. They significantly impact weather patterns and storm movement, influencing the climate of mid-latitudes, including regions like the United States and Western Europe. Polar winds. These winds emerge near the poles and flow towards lower latitudes, eastward. These winds contribute to the formation of polar deserts and play a role in shaping the climates of polar regions. Periodic winds. Certain winds tend to reverse their direction periodically. These winds blow in a definite direction during a particular period of the day or year. Such winds are called periodic winds. They are caused by the unequal heating and cooling of the Earth's surface and the localized difference in the atmospheric pressure. The main types of periodic winds are the monsoon winds and land and sea breezes. Land breezes. These occur at night when the land cools faster than the sea, creating a pressure gradient that induces breezes from land to sea, providing relief from daytime heat along coastal areas. Sea breezes. Conversely, sea breezes, prevalent during the day, result from the land heating more rapidly than the sea, causing warmer air to rise and drawing in cooler air from the sea, offering a cooling effect to coastal regions. Monsoon winds. These are characterized by seasonal reversal in direction, play a pivotal role in the climate of regions like South Asia. During summer, land heats up, drawing in moist air from the sea, leading to moist air from the sea, leading to heavy rainfall and a crucial wet season. Local winds. In many parts of the world, winds with special characteristics blow over small areas. These winds blow for a short time. Such winds are called local winds. Most of them are seasonal and their names are usually derived from the regional languages. Some local winds are Lu, Chinook, Foyhan and Harmattan. Moisture. Moisture in the atmosphere exists in solid, liquid and gaseous states. The amount of moisture present in the air varies from place to place and from time to time. The air in the equatorial region has more moisture than other regions of the world. The air has more moisture during the summer season than during the winter season. The amount of moisture decreases with the increase in height above the mean sea level. The amount of moisture is almost zero in the cold air of the polar regions during the winter months. Evaporation. The most important form of moisture in the atmosphere is water vapor. It is added in the atmosphere through evaporation of water. It is also added from the moist ground and from plants and animals through transpiration. Evaporation takes place everywhere, always and at all temperatures. The rate of evaporation increases when the air is hot, dry and windy. It decreases when the air is cold, moist and calm. Humidity. The actual amount of water vapor present in air is called humidity or absolute humidity. It is closely related to air temperature. When the air holds the maximum amount of water vapor at a given temperature, the air is said to be saturated. An important and useful way of expressing the level of humidity is in terms of relative humidity. It is defined as the ratio between the actual amount of water vapor present in the air at a given temperature and the maximum capacity of the air to hold moisture at that temperature. Condensation. When moist air rises upward, it becomes cool and the water vapor changes into small drops of water. This process is called condensation. Condensation takes place around dust particles in the air. The important forms of condensation are dew, fog and clouds. When small drops of water condenses around dust or smoke particles in the air, the mass is called cloud. Clouds move from one place to another even by light air movement. Depending upon their shape and the height at which they are formed, there are three types of clouds. These are cirrus, cumulus and stratus. The rain-bearing clouds are given the prefix or suffix nimbus. Precipitation. When small water drops join, they grow in size until they are unable to float in the air. Then they fall down as raindrops or flakes of snow. This process is called precipitation. The main forms of precipitation are rain, drizzle, snow and hail. Types of rainfall. Rainfall is the most important form of precipitation. Depending upon how warm and moist air cools, rainfall can occur in the following ways. Convectional rainfall. When air encounters the hot surface of the earth, it gets heated, becomes light and rises in the form of air current. After the warm air reaches the upper layers of the atmosphere, it expands and loses heat. This leads to condensation and the formation of cumulus clouds. These clouds produce sudden and heavy rainfall accompanied by thunder and lightning. This is called convectional rainfall. It is experienced every day in the equatorial region. Orographic rainfall. When a mountain or a hill comes in the path of moisture, then winds is forced to ascend along its the moist air mass is forced to ascend along its slope. As the air mass rises upwards, cooling takes place. This is followed by condensation and precipitation. This is called orographic or relief rainfall. The windward side of the more rainfall than the leeward mountain gets side. Cyclonic rainfall. This type of rainfall is associated with cyclones in the generally tropical region and depressions in the temperate regions. In a cyclone, when warm and cold air mass meet, the lighter warm air mass overrides the cold air mass. The boundary between the two air masses is called front. Condensation takes place in the warm air mass and rainfall occurs along the path of the cyclone.